Assalamualaikum and good afternoon. Today we going to proceed with chapter 6 structural steel column design. Okay, last week I explained about the theory, and this week we're going to have a look at the example number 1 for this chapter. Okay, example number 1, a 5 meter long internal column in rigid jointed steel structure is loaded with 800 kilonewton dead and 1200 kilonewton imposed load. Okay, so that one is for the loading. And then assuming that the fixity and at the top and bottom of the column give effective rotational restraint. Okay, so fixity at the top and bottom of column. So here they just explain about rotational, meaning dia boleh berpusing atau tidak. Actually this question tak ada mention at all about the position. So position ni bila dia tak ada mention, maksudnya it can be braced ataupun it can be unbraced. So therefore dalam soalan ni dia minta you check for brace and also unbraced, because position ni dia tak ada mention. Normally bila position is mentioned, so it can be whether brace ataupun unbraced kan, but here since position is not even mentioned, so the column perhaps it can be braced ataupun it can be unbraced. Okay, so here yang 800 kilonewton ni adalah GK and 1200 is QK. Alright, so first we need to kira the effective length. So how we going to do that? Okay, so design axial load 1.4 GK plus 1.6 QK using this infamous formula. So you're going to get 1.4 times 800 plus 1.6 times 1200, you're going to get 3040 kilonewton. Alright, so after that we need to check, because okay, since they not mention whether it's braced ataupun unbraced, and the question itself pun mention that you have to calculate for both, so kita kira for braced column dulu. Okay, since it is here A brace, so kita kira for braced column. So effective length is equal to LE times 0.7 length equal to, okay, sebab ini 5 meter ni adalah the length of the column, which is given in the question 5 meter here. Okay, so kita pun ambil the value of L is 5 meter, so you get 3.5. so how do I get this 0.7 if the factor here? So we have to refer to the table. So which table? Actually this table, this table, because we need to see which one is how is actually the condition of restraint at the end, meaning the fixity at the end. Kita refer balik to the question. Okay, assuming that the fixity at the top and bottom of the column give effective rotational restraint. Okay, bottom and top dua-dua sama effective rotational restraint. So let's check here. Because position dia tak state. Okay, so when position not being stated, it can be braced or unbraced. So both restraint maksudnya rotational restraint, meaning restraint in direction. Okay, this one. Okay, because you know that number 1 up until number 4, this is braced column, braced type, and number 5 up until number 7, this is unbraced. Okay, And okay, kita boleh juga tengok for unbraced terus, because basically this thing lebih senang kita nak faham if we discuss it macam mana keadaannya untuk dua-dua sebab dia tak cakap pasal position kan. So one end is effectively held in position and restrained in direction. So position not even being mentioned, so lantak pi dengan dia. But it is restrained in direction. Okay, so one end is restrained in direction, meaning meaning that memang akan ada keadaan yang akan unbraced, because direction dia tak position tak mention, but just mention that effectively held in direction at both end. Okay, ataupun rotationally restrained, benda yang sama lah sebab direction tu sama dengan like rotation lah ya. And the other end is must be also restrained in direction juga. Okay, because of dia cakap tadi effectively restrained in fixity of the column is lupa ayat dia. Effective rotational restraint. Okay, so effectively restrained in direction lah. So this one is restrained in direction, one end, bawah ni memang dah restrained in direction, and at the other end also it is restrained in direction. Okay, position not being mentioned at all, so it can be whether unbraced ataupun braced lah, sebab this one pun also dia mention pasal position, but we don't care about position, we are just care about the direction right now. So it can be braced and it can be unbraced also. Okay, but if let's say you have the question yang perhaps it mentioned about the position and the direction, it can be either the brace ataupun unbrace, salah satu. Tak bukan you kena kira dua-dua. Kalau dia memang bagi like one condition yang macam tu, like position is like this and the direction is like this, so mana salah satu ni lah. Okay, you kena tengok on the condition here. So that's why this table is very important for you to understand. So for brace is 0.7, for unbrace is 1.2, but since we're going to calculate for brace first, so we take this value 0.7L for our question here. Okay, so that's why I dapat 0.7 here. So the effective length is 3.5. Okay, so biar dulu. Okay, after this is a bit confusing for you because you need to try. You kena ambil je any section that you refer to the UC section. Okay, the UC section here that you refer, you can pick any section. Okay, but when you selecting section, you cannot select section that is too big, because when it is too big, it can be over design. Okay, sebab sebenarnya you don't need that the sizing is not that as big as what you should actually design. Sebab kalau you design terlebih besar, the structure going to be very heavy. Then what happen is you going to, because this one is column kan, later on it will be transferred to the foundation, and since the self weight of the column itself is big, so foundation you akan dapat bigger loading, bigger moment, and it will cost a bigger foundation, which is not economic and cost you more. Okay, so that's why when we design, we need to consider optimal design. Alright, so here I just select 254, 107 UC for the first my selection lah. I try first. Okay, first kita kena tengok dulu the value of PY, since you know PY is steel strength. Okay, so kita dah ada section that we select randomly. Okay, select je random. Okay, semakin ke bawah, as you know semakin ke bawah dia semakin kecil smaller. So if you go higher up above the table, so the section is going to be bigger. So since this is braced, I know that the effective length must be lower, since 0.7 kan you tengok factor dia. So normally you punya structure takkan jadi sangat besar lah. I mean the column itself, the size not going to be as big as Unbraced. Okay, like that. Okay, so I just choose this section and look at the value of t, which is 20.5 here. Okay, so the value of t, we know that, sorry, what is it again? 20.5. So the value of t here is 20.5. Okay, so kita nak check kan whether py is 275 ke, 265 ke, 255 ke, 245 ke, we don't know. So since t is bigger than 16 but less than 40, so obviously our py is 265. So our py is 265. Refer again here. Okay, so that's why t is bigger than 16 mm but less than 40 mm. You can, ataupun you nak tulis, because this is, we know that when it is more than 16 mm, less than 40 mm, py adalah 265. Okay, and then kita kena juga check the classification to make sure that section is not slender. Okay, why we need to check this? Because formula, if let's say the section is slender, is different from compact, semi-compact ataupun plastic. Okay, kita just kena make sure je dia bukan slender. Okay, the chart that we need the value of b over t and d over t again. Kita check je dekat our section here. Okay, value of b over t and d over t, which is 6.3 and 15.4. Here. Okay, and then kita kena compare dengan this 9 constant and 40 constant. So 9 constant and 40 constant ni basically from the same table yang you tengok sebelum ni. I tak provide this table kah? Okay, kejap ya. So 9 constant is here. If you look at here, 9 constant ni kat sini lah. And for B over T, okay, outstand element of compression flange roll section. So element yang in compression. Because when we look at column, sebab element dia, as I explained in our previous class, dia being, the element is, the section is resisting compression punya force, compressive force. So anything about compression is related to column. Okay, so for B over T is 9 constant. Sama je this table dengan table B. Okay, doesn't matter kalau you dapat 9 constant ke, 10 constant ke, 15 constant ke, as long as dia within this range, maksudnya dia bukan slender lah. And another thing is where the whole section is subject to compression roll section for D over T. So D over T we have like 2 choices here. So yang first ni biasa kita pakai is for beam. Okay, yang D over T here. Okay, D over T here is for beam. And this one is for column. Because nampaknya ada compression roll section. Okay, so 40 constant. So compact, semi-compact ke, plastik ke, semua sama 40 constant. Therefore, when we look at here, B over T and D over T, it is less than 9 constant and also 40 constant. So ini sebenarnya bukan plastik. And also this one pun can be plastic, compact ataupun semi-compact. Sebab 40 constant ni sama je. Compact, tak kisahlah. Okay, as long as dia bukan slender, section is not slender. So that is the main thing that we are classify we classify the section. And then what we need to do next after we classify if not slender, so that's all good. We can proceed with checking the x-axis and y axis of the section. As I mentioned in previous class, kita kena check for both because of column you stand like this, so it can be like if you check x and y kan, dia macam kalau arah sini adalah x, arah sini adalah y. So kita kena check both sebab dia standing punya element of structure. First kita check Rx, which is the radius of gyration. So since it is for x-axis, kita check Rx. So kita tengok on the this one where is Rx? So the radius of gyration, this is 11.3. So 11.3 it is in centimeter. 11.3 centimeter. So here bila you tukar dia in mm, dia akan become 113 mm. And we know that to check the slenderness ratio, it is effective length divided by radius of gyration. We have the effective length that we calculated in previous slide, 3500 divided by this radius of gyration, you get 30.973. And what we need to do next, kita kena refer to table. So which table? Sebab kita nak tahu kan, we have the curve A, curve B, curve C and curve D table. So this is when we going to refer to that compressive strength table, which is this one lah. Okay, so sebab sekarang ni kita ada table A, table B, table C, table D, macam yang previous my previous class I explain. So how we going to check which table yang kita nak pakai? Okay, so we have the value of T. So since section for what is it, column ni adalah H section so you just refer to the one yang down here, whether it is up to 40 mm or over 40 mm. So here we refer to the thickness. Okay, so for the thickness again, I dah lupa berapa value thickness kita. Tengok kat sini pun boleh. So it is 20.5. Okay, 20.5 ni dia. Okay, so we can refer to that 20.5. So it is up to 40 mm. Okay, up to 40 mm. Dia tak over lagi, dia belum lagi lebih daripada 40 mm. So when we refer, which table kita nak refer, so kita akan check on table curve B and curve C for YY. So sekarang for kita tengah calculate for curve B, for XX. Jadi kita akan refer to curve B lah. Okay, so refer to curve B. Kita check kita punya slenderness ratio balik 30.973. Okay, and refer to table curve B. So here I have the curve B table. Okay, 39.7. Allah, apa lagi? 30.973. Okay, it is 30.973. So that is the value of our slenderness ratio. Okay, so we know that this is curve B for XX. Okay, 30.973. So you see here tak ada 30.973. Dia ada 30, 35. So kita pun tak tahu yang mana satu. And at the same time, we have like 235, 245, 265. So this is all PY. Okay, S ni you jangan tengok lah. S ni sebenarnya dia punya like dia punya family lah. Family of S275 is S235 Family of S275 is 235 until 275. Family of X355, 315 sampai 355 like that So for this S275 sebenarnya ini family dia lah. Okay, dia punya adik-beradik, anak-beranak dia kat situ. Okay, so since you punya PY is 265, so kita kena tengok dekat sini. Can be anywhere here lah. Okay, in between this value, since 30.973 is between 30 up until 35. Okay, so kita kena kira. So macam mana kita nak kira? So we know that when macam mana cakap? When bila dia 30, okay, dia ni 253. Okay. And then sekarang ni kita nak 30.973 equal to value yang we don't know, which is PY lah, which is what we're trying to find. The steel, the design strength, steel design strength there, compressive strength there. Sorry, PY pula, PC, compressive strength. Of this steel and then when it is 35, it is 247. So macam mana kita nak dapatkan value ni? So what we can do is we can do something like this lah. Kita boleh cuba, okay, kita ambil 30.973 minus 30, it is equal to PY minus, tak muat lah, $30.973 minus 30 sama dengan PY minus 253. Okay, maksudnya okay, you ambil value 30.973 tolak 30, PY tolak 253, macam tu lah. And then we can also do 35 minus 30 sama juga dengan 247 minus 253. Okay, so sekarang apa yang kita cuba buat, sebab ni this one dia macam ada 3 benda and one unknown Make sure that bila you tolak, you can tolak mana-mana you suka. Contohnya what I can do is I boleh ambil value 30.973 minus 35 PY minus 247. Okay, that is one. And then 30 minus 35, 253 minus 247. Just make sure that you punya unknown ni hanya ada satu sahaja. Okay. Kalau you ambil this one, tolak dengan this one, nanti you akan pening sendirilah. Okay. Kalau you tak faham on that part, you can ask me later on. Okay. Sebab this one is a bit confusing for some people. Tapi I suka tolak lagi macam like 30 minus 30.973 minus 30 sebab dia lagi senang kira compared to you ambil value 30.973 minus 35, nanti you can tekan calculator kan. That is one of the reason lah. Okay, so I simplifykan this one. Okay, 5 terus kira. Allah, ni 25 berapa ni? 253. Sorry. Okay, 247 minus 253 is negative 6. Okay, so right now we have ni lah, ni kita cuba selesaikan. So what we need to do is we need to darab silang. Okay, cross multiply. Okay. So when I cross multiply, so this is the value that I dapat lah. 6 darab 0.973 negatif 5.838 and 5 darab PY is 5 PY and 5 times negative 253 I dapat negatif 1265. Okay, so kita boleh dapat the value of PY. So we can finally get this value. Okay, so this is the value that I dapat akhir sekali. So how do I get this? So negative 1265 you alihkan ke sini, so negative 5.838 plus dia jadi plus lah 1265 and then you divide by 5. So here I got 251.832. Okay, so that is the value of our PY. Sorry, PY lagi. Kenapa aku asyik tulis PY? It's not PY. I'm sorry. You must be confused with me. Okay, so here is PC actually. PC, the compressive strength. Sorry guys. Okay, so here it is PC, compressive strength. This is what we're going to find. Okay, yang kita nak cari. So PC is 251.832. Okay, So this is the value I dapat lah. Okay. PC X. So X meaning that dia arah X axis. And then we leave it like that. And the next thing we need to do is we need to check for Y axis pula. Okay. So RY is 65.7. And where we get this, again, we refer to this table. Here it is. 6.57. So in centimeter, when it is converted into millimeter, it becomes 65.7. And then we calculate the slenderness ratio. Just pick the value of effective length divided by the radius of gyration. Y axis, you get 53.272. And again, we need to look at which table yang kita nak check untuk kira the value of PC, which is the compressive strength. So nak tengok benda tu, again kita refer to this table. And sebenarnya kita dah tahulah, tadi pun I dah bagi tahu yang YY you use the curve C table. Okay. And then what we need to do, kita tengok pada that table. But before that, let us check again what is the value of I lupa. 53.272. Okay, 53.272. Look at table PC curve C. Alright. So it is 53.272. Let me check again. I takut salah lagi. Yeah, betul. Alright. 53.272. And we know that our PY is 275. So kalau kita tengok sini, PY 275. And then when it's 53.272, it must be between this value for the slenderness ratio. Okay, but the problem here is tak ada value 53.272, so it must be around this value. So kita akan kira guna cara yang sama, PY 265 and slenderness ratio 53.272. Alright. So when it is 52, value of PC is 210, and when it is 54, value of PC is 205. Sorry, I lupa. Okay, so we can use again the same technique that we just minus the 53.272 minus 50 equal to, okay, and 54 minus 52. Alright, and we can simplify this. 1.272 equal to PC minus 210. Simple as that. You tak payah kira susah-susah sebab this is simple je. That's why I suka tolak cara macam ni, sebab senang lagi tolak kan. Kita tak payah susah nak tekan calculator for this one. Okay, but then this one I kena tekan calculator sikit. We just darab silang saja. Okay. Okay, I dapat this one 5.088. Darat 4 darat 1.272 dapat 5.088. And 2 darat PC, so 2 PC 210 times 2 negative 210 times 2 become negative 420. So we can finally finish off the calculation. And I dapat 207. 0.456. Okay, one thing that you need to be very careful, bukan not very careful lah, sebab takut macam you ada salah kira perhaps because dia jalan kerja dia a bit confusing sikit. Okay, satu cara you boleh check the value PC you 207.456. You tahu kan dia in between this 52 and 54. So value ni takkan lebih daripada 206 but takkan kurang value dia takkan kurang daripada 206 but takkan lebih daripada 210. Dia must be in between this value lah. Okay, so 207.456 make sense Takut kalau salah kira kita boleh check dari segi tu. Mungkin kalau dia okay, so kita boleh confident sikit lah to proceed. Alright, so here sama I dapat 207.456. Okay, so when you get these two value you akan ambil value yang paling rendah to calculate the PC here. So PC kat sini is compressive resistance. So kalau you nampak ini, there is like small PC like this. Okay, so this is what we call as compressive strength lah. Yang you kira PCX, PCY tu. Okay, and we have like big PC. This one is compressive resistance, meaning that the capacity of the column to resist compression force. Okay, so PC ni kita kena calculate using the formula of AG. AG ini is the gross area the area of the column lah, gross area of column, and then darab dengan compressive strength. Okay, so compressive strength we have YY, we also have XX. You pick the number which is the lowest. Okay, kenapa which is the lowest? Bila you dapat compressive strength yang tinggi, maksudnya on that axis dia memang boleh support. Tapi how about the other axis? Kan, so another axis yang lebih rendah value dia punya compressive strength is the one yang kita worry, sebab kita ada dua axis, sebab dia memang pakai X and Y, both axis pakai. So kalau this one is weak but from this one is weaker than this one, this one is weaker than this one, so macam mana pun okay, nanti from Y axis dia akan fail tapi X axis dia tak fail. But we cannot let it happen like that. Both of the axis can resist the compression load. Okay, jadi kita akan compressive load, compressive force. So kita akan ambil value yang lebih rendah. Okay, which is Y section ni lah. Kalau you compare B and C, look at Y 207.456. So this is the one that we put here. Okay, and look at here the AG. AG here is gross area of column. Mana you tengok, you boleh check dekat section. Okay, area of section 137. Okay, that is this area dia 137. That one in centimeter square. So when it is in centimeter square, maksudnya 137 centimeter square, you convert it, maksudnya you kena darab dengan 2 kali darab 10 lah, maksudnya you darab 10 sekali darab 10 sekali, sebab centimeter tukar pada millimeter darab 10. Bila power of 2, it means that you kena darab 10 2 kali lah. Okay, and you will get some values which is in Newton. Since this one you cancel out dengan this one, you akan dapat dalam Newton. And here I divide with 1000 because I want to convert it into kilonewton. So you dapat 2842.147. So when we get this value, so ini adalah final answer kita, whether it's wrong or it's right, because kita assume the section. Okay, the section is not given in the question, you yang cari sendiri. So you kena check lah section yang you suggest tu betul atau tidak. Okay, you nak compare dengan apa? You kena compare dengan the axial load yang you calculate masa awal-awal, which is here. Okay, 3040. So 3040. Okay. Oh, sorry, 40. 3040. So value ni not okay since 2842.147 is less than 3040. So maksudnya sekarang sepatutnya section kena provide higher compressive resistance compared to the axial load yang acting on the column itself. So this one not safe lah, maksudnya loading lebih besar daripada compressive resistance capacity of you punya load column itu sendiri. Okay, so bila tak okay, then we need to suggest another section. Okay, so here I suggest kena redo balik semula everything from the start. Okay, so 254.254.132 you see. Okay, tadi kita ambil 107, so I besarkan satu size saja besar kat sini because beza dia tak besar sangat kalau you tengok here the value is not that much difference, around tak sampai 200, around 200 lah, 200 something so it's not that big, so I besarkan satu sahajalah size dia. That's why I suggest 254.254.132 you see. Same again, we look at the value of T, which is 25.3. Ini mana dapat, look at the value of flange here. Thickness is 25.3, which is bigger than 16 but less than 40. Okay, bigger than 16 but less than 40. So since it is bigger than 16 but less than 40, PY akan jadi 265. Alright, and then we classify again the section. So since the 265, the constant is PY ni you replace lah 265. So tak macam beam sebelum ni bila you kira every time like PY is 275. Tapi it can be 265 also. That's why you have to check. The value of T tu penting that's why you have to check. So since the value of T you more than 16 but less than 40, then you dapat PY 265 ni lah. And then you kira you dapat the constant is 1.019. And again check for B over T and D over T. B over T and D over T 5.16 and 12.8. Okay, 5.16 and 12.8. Okay, and check again with this table. Okay, look at here the one above here, just make sure dia bukan slender, meaning dia tak lebih daripada this 15 tak constant, and also check here also supaya dia bukan slender. Bila kita check which is exactly value dia memang less than 9 constant and less than 40 constant. Okay, which means dia bukan slender lah. So yang dalam kurungan ni bila saya darab 9 times constant ni, which is 1.019, dapat this value and 40 times the constant itself 40.76, and both values shows that the column is not slender section. Alright, and then we go to the next one. What we need to do is kita nak check dia punya PC again, which is the compressive strength. Rx equal to 116. Where we got this? We look at the table, which is the radius of gyration. Okay, 11.64 x-axis and 6.67 for y-axis. So simply kita boleh je terus tulis kat sini, tak payah nak refer banyak-banyak kali Okay, 11.6 116 mm lah, because that one dalam centimeter and this one is 6.67 centimeter, it becomes 66.7 millimeter. Okay, for yy. And we can simply calculate the slenderness ratio by dividing the effective length with the radius of gyration, arah xx 116, you dapat 30.172. And arah Y, terus kira arah Y, 3500 divided by 66.7 dapat 52.4674. And then kita kena tengok which table kita nak pakai for untuk kira dia, untuk dapatkan dia punya compressive strength. Nak refer pada which table, curve A ke, curve B ke, curve C ke, curve D. Okay, we have so many table. How we going to check that? Kita akan tengok pada value of T. Okay, for our section here it is 25.3. So when it is 25.3, we know that when it is tengok yang kat bawah ni saja. So 25.3 is up to 40 mm. Sama juga you akan check curve B and curve C for X axis curve B and Y axis curve C. And then so curve B, okay, and curve C. Okay, jadi saya pun check lah. Okay, so 30.172. Okay, so slenderness ratio is 30.172. Betul takut salah lagi. Okay, alright, so bila 30.172, PY is 265, it must be dekat sini alamak, kenapa macam ni? It must be at this area and okay, 265 so this one lah, between 253 and 247. Okay, 30 is equal to 253. 30.172 kita tak tahu berapa PC, and then 35 is 247. Okay, just simplifykan this one. So 35 minus 30, kita boleh tulis macam ni pun boleh. Okay, we can just simply tulis macam ni, and then kita simplifykan dia lagi. 5 equal to negative 6, okay, and 0.172 equal to PC minus 253. Okay, and then kita boleh calculate lah darab silang, the cross multiply kan value. So when I cross multiply, I get something like this. Okay, and then what we need to do, kita akan dapatkan the value of PC kat sini. Okay, kira sahaja I dapat 1000, negative lah. I dapat 252.794. okay, so 252.794, kita tengok macam mana kita rasa macam, okay, kita nak check. So make sure that it is in between these two numbers. So probably betul lah 252.794. okay, I pun dapat jawapan yang sama. Okay, for XX. And then kita boleh kira for YY. So YY tadi I dah explain semua sampai sini, and kita dah tahu table C yang kita nak pakai. Just pick this slenderness ratio which is 52.474. Check dekat curve C, 52.474. okay, curve C, Allah, apa tadi, 474. Alright, and then kita tengok kat sini. So 52.474 obviously tak ada, it between 52 and 54. On pre-Y is 265 ya. So inilah in between 206 to 210. Okay. So kita boleh calculate with cara yang sama juga. When it is 52, it is 210. And when it is 52.474, we don't know. And then when it is 54, it is 206. Okay. And then kita just kira cara yang sama. You nak pakai cara yang macam I kira yang mula-mula pun sama je sebenarnya. 54 minus 52. Okay, simplify kan. Okay, so kita boleh cross multiply. Okay. Okay, so bila saya cross multiply dapat macam ni. So 2 darab PC. 2 darab negatif 210. So this is what I got. 420, sorry ya. Okay, and then 0.474 darab negatif 4. So negatif 1.896. Okay, so we can get the value of PC. So here I dapat 209.052. Okay, so 209.052 the value of PC for y-axis. Alright. Okay, sama. So from these two, as usual, kita ambil value yang paling rendah. So y we see here is lower than xx. The value of PCX dengan PCY ni 209. So that one yang kita akan masukkan dalam formula of PC equal to AGPC. Compressive resistance equal to area darab dengan compressive strength. Okay, so AG is 16,900 mm square. So mana dapat benda ni? As usual, look at the table. 169 This one adalah in centimeter square. So bila dia dalam centimeter square, you kena convert. Dia akan jadi darab 10 darab 10. Okay, that's why 16,900. Darab dengan this one, I dapat 3532.979 kilonewton, which is bigger than 3040 yang kita calculate masa kita kira axial load. Okay, mana dia? Yang mula-mula tu lah. Okay, 3040. Alright. Okay, we are done with brace column. Okay, brace column kita dah dapat. Memang dia lebih, dia okay lah. Since kita punya section tu compressive resistance dia lebih besar daripada the axial load. Okay, kalau you tengok value dia tak beza banyak which is this is what we want lah, optimal design. Kita tak nak over design. Okay, then we can proceed with calculate for unbraced column. Okay, tadi pun kita dah bincang pasal the effective length when it is unbraced. Axial load you tak perlu kira lagi. Axial load dia memang macam tu sebab soalan dia bagi imposed load dengan dead load dia sama. Jadi kita tak perlu kira banyak-banyak kali. Boleh terus design untuk dia punya section which one that we want to use. So using the effective length 1.2 L times 1. Equal to 1.2 times 5 meter, the length, you dapat 6 meter. So kalau nampak effective length ni become very, you punya column ni lagi tinggi daripada the actual length dia. Okay, so that's why kita kena suggest bigger size. So kalau you nampak kat sini, I try terus 305, 305, 198. Size yang lebih besar. Okay. Sebab tadi kita ambil 254 if I'm not mistaken, 254, 254 something. Okay, so I terus ambil size yang besar kat sini. Tak besar sangat lah. Kita try and error basically this one I select random je. Because I assume, because I nampak like macam dia punya effective line lebih tinggi, so should be size dia kalau loading yang sama kena pada the same column, but we use a different connection dekat end of the column, and connection dia different. So kita assume, kita akan anggap like it is 1.2 times 1 meter, so lebih besar. That's why I ambil like bigger size of column lah. Okay, jadi kita check dulu the value of T here by looking at the kita punya column yang kita select. Here is 31.4 and 31.4 T, sebab kita nak tahu PY dia berapa, it still masih lagi besar daripada 16 but less than 40, so PY is 265 here. Okay, so because of that ada macam ni lah. Okay, and then section classification, kita kena check value of B over T and D over T again. B over T is 5 and D over T is 12.8. Okay, 5 and 12.8, and then check with the table yang this one lah. Okay, B over T and D over T. Okay, 5 is less than 9 constant and D over T it must be less than 40 constant. So kita anggap dia as slender column. Untuk kita anggap dia bukan slender column. So kita anggap dia, kita design dia untuk jadi bukan slender column. Apa aku nak cakap ni? Alright. Therefore, bila kita kira, so kita dapatkan the value of constant here, since PY 265 dapat 1.019, 1.019 darab 9. Number 1, obviously ini adalah dalam geng plastik, and this one dalam geng plastik semi compact ataupun compact lah. Okay, 40 constant ni. So section is not slender, so that is the most important kita kena tahu And then as usual kita nak cari PC again. XX 142, the value of RX kita refer to the table. Tengok radius of gyration again, 8.02 for YY and XX dia 14.2 and 8.02. Okay, so this is 14.2 cm tukar meter and 8.02 cm tukar millimeter. So you dapat this value. So as usual you divide je dengan nak dapatkan dia punya slenderness ratio. The effective line divide by radius of gyration. Do it for both YY and XX. Okay, and then again kita dah dapat value from table. So which table we going to use again? Table B and table C. Mana kita tahu table B, table C? Seperti biasalah, since kita punya T kat sini tadi adalah 31.4. Okay, so 31.4 is, tengok belah bawah saja, up until 40 mm. So masih lagi this one and this one So 27B, sorry 27 ni abaikan, curve B and curve C. Okay, so curve B and curve C. So kita dah tahulah that is dua jenis yang kita nak pakai. Okay, so dekat sini I'm not going to show you macam mana you kira, because I believe that sebelum ni I dah tunjuk, so you boleh try to calculate yourself. Jawapan dia I dah bagi dekat sini. Okay, this is what I got. Okay, kalau you dapat jawapan dia lain, maybe kita boleh discuss balik. And for YY pun I dapat like this lah, the answer Okay, just make sure that you refer to curve yang betul lah for this one. And then you darabkan, pilih value of PC yang paling rendah compared XX dengan YY ni. I dapat PCY is lower, 167.374. I darab dengan the value of area of column, which is this one lah, 252 cm square, tukar kepada millimeter square, you akan dapat 252 200 mm square. Darabkan saja, divide by 1000 sebab you nak convert dalam kilonewton. I dapat 4217.825, which is bigger than 3040, which is okay. So kalau you nampak beza kat sini agak besar, about 1200, lebih kurang lah. Okay, 1100 something. Okay, but it is okay lah sebenarnya, because 1000 kilonewton tu lebih kurang macam 1000 kilogram lebih you provide. Okay, so not that bad lah sebenarnya. Okay, tapi janganlah provide sampai 2000 lebih, 3000 lebih. So it is overly designed. Okay, tapi sebenarnya if like this is also unacceptable. Sepatutnya kita kena redesign balik, pilih the optimal design, choose lower section. Maksudnya section lebih kecil. Mungkin you boleh pilih section macam section like this kah, 158 ke, 305, 158, 305, 137 kah. Kita boleh try section yang macam ni lah. Okay, sebab normally, sebab tadi bila you dah kira brace, you dah dapat 254 ni memang sebab dia for brace, so dia punya effective line dia lebih rendah. So sebenarnya dia boleh pakai section lebih kecil compared to unbraced, ya. Okay, so I rasa itu saja for this class. So ini you boleh kira sendiri, check dengan my answer so that you boleh have the idea. If let's say you get a different answer from mine, we can discuss. Okay, thank you so much. Have a nice day, everyone.